All right, so you're ready to move past the AWS console and start really controlling the cloud directly from your code? Well, in this explainer, we're going to dive deep into the AWS API. That's the engine that powers all the automation, and we'll figure out the absolute best way to command it.
Look, we've all been there, right? Clicking around in the AWS management console setting things up. But what happens when you need to create, say, 100 users at once, or build a system that automatically scales itself? That whole manual click and pray process just doesn't scale. And that's the exact problem we're going to solve today.
Well, the answer is something called the Query API. You can think of it as basically the universal language for talking to AWS. So instead of mouse clicks, you're sending these really precise, structured commands over HTTPS. This is the foundation, the very bedrock of all AWS automation. Okay, first things first. Before you can even think about sending a command, you've got to know where to send it. You can't just shout into the void of the cloud and hope for the best. You need to find the right front door.
Think about it like this. Every single AWS service, whether it's S3 for your storage or IAM for identity management, it has its own unique address, its own front door. In the tech world, we call this a URL, or an endpoint, and it's the official address where that service is just waiting to receive your API calls. And for some of the really core services, this is super simple. For example, Identity and Access Management, that's IAM, and the Security Token Service, or STS, they each have just one single global endpoint. It doesn't matter where you are in the world, these are the two addresses you're going to use to talk to them.
But here's a little pro tip for you when it comes to the Security Token Service. While that global endpoint totally works, AWS actually recommends you use regional ones instead. And why is that? Well, it's because sending your request to a server that's physically closer to you means less travel time on the network. We call that latency. That one small change can make your whole application faster and a lot more reliable.
All right, so we've found the address. Now let's talk about probably the most important rule of this whole conversation. It has to be secure, no exceptions.
And the official documentation, it couldn't be clearer about this. You're handling extremely sensitive data here. We're talking security credentials, user information, permissions. HTTPS is what wraps all of that data in a protective layer of encryption as it travels across the public internet.
So yeah, this isn't optional. It's not a suggestion. It's absolutely non-negotiable. Sending a request over plain HTTP would be like mailing your bank password on a postcard for literally anyone to read. HTTPS is that sealed, tamper-proof envelope that keeps it totally private. But, just having a secure connection, that's only half the battle. How does the server on the other end know that the request is actually from you? And maybe even more important, how does it know the request wasn't sneakily changed along the way? And that, right there, is where something called request signing comes into play. You can think of it like a digital wax seal on an old-fashioned letter. It's this really sophisticated cryptographic process that proves your identity and guarantees with mathematical certainty that the request hasn't been tampered with.
So how do you make this signature? Well, you use your two main credentials, the public access key ID and the all-important secret access key, which, by the way, you need to guard with your life. These keys get fed into a special algorithm, and out comes the signature. And AWS is very clear. You need to use the latest, most secure version of this process, which is called Signature version 4. And this brings us to a golden rule. One of the most important principles in all of cloud security. Do not, I repeat, do not use your root account's access keys for this stuff. Those are the keys to your entire kingdom. Instead, you create a dedicated IAM user with only the permissions it needs. Or, even better, you use the security token service to get temporary credentials that just expire after a little while. The principle is always, always least privilege.
Okay, so let's recap. You've got to manage endpoints, you've got to make sure everything's HTTPS, you've got to correctly sign every single request. That's a lot of work, and there are so many places you could mess up. There has to be a better way, right?
Seriously? Trying to do all of this manually? It's just a recipe for a headache. You have to find the right endpoint, make sure it's HTTPS, and then correctly implement that super complex Signature version 4 process for every single API call. It's incredibly easy to get wrong.
But what if you didn't have to do any of that? What if there was a tool that could handle all that complicated heavy lifting for you? Well, that tool exists, and it's called the AWS Software Development Kit, or SDK.
Just look at the difference here. When you use an SDK, that whole complex cryptographic signing thing, yeah, it's handled for you. What about managing errors when things go wrong? Or automatically retrying failed requests? Also handled. The SDKs just take care of all the tedious, low-level stuff so you don't have to.
And the best part is, these SDKs, they're available for pretty much any language you can think of. Java, Python, Ruby, Go, .NET, you name it. They're just pre-built toolkits that make talking to an AWS service feel as natural and as simple as calling a regular function in your own code.
So really, what this all comes down to is this. By letting the AWS SDKs handle all the complicated, nitty-gritty mechanics of API calls, of security, of errors, you get to focus on what actually matters, building your application. The tough stuff is already solved. So the real question left is, what are you going to build with all that power?